Hello everyone, hope you've had a good March break. It's Mr. Melly here. Interesting times. I hope you're all healthy and safe and well, and your family is too. I myself am getting over a cold, but it's not a big deal. Welcome to my home. We're in the basement right now. My cat Tiger is just chilling over here on the sofa. You can say hi to him. Hi Tiger. And what we're going to do is we're going to try to do a little math lesson from home. Okay, never done this before. I'm guessing you never have either. You should have a handout. I would have given it to you on the Thursday, the second last day of class before the March break. And I think you were supposed to have tried the getting ready from chapter 5. We're going to keep moving. Here it is, March 23rd. We're going to carry on just like we're in school. Well, not just like we're in school, but kind of like we're in school. And I'm going to make a short video and see how this goes. If you guys like it, and maybe we'll keep trying. If not, maybe you can have some suggestions and we could try some other stuff. So, first page inside the package, example 1. When traveling 500 kilometers to Deep River, Ontario, Nadine's family's distance in kilometers with variable d varies directly with time t in hours. We are supposed to find the equation that relates d to t. This is a direct variation question. We'll see what that means a little bit later. Basically, their distance varies directly with time. Okay? The longer they drive, the further they drive. There's a direct relationship. And it says that d is 60. I guess that means 60 kilometers, 60 kilometers, when t is 0.5, which means if they drive for half an hour, they will drive 60 kilometers. Okay? But we're supposed to find an equation. Well, before we find an equation, let's play around with the numbers a little bit and see what we can see. I'm going to draw a number line, and our number line is going to start at 0 because, well, when they drive for 0 hours, they will drive 0 kilometers. But we also know that if they drive for half an hour, so I'm going to put time at the bottom here, when they drive for half an hour, they will travel 60 kilometers. Okay? Well, let's extrapolate that. What would it mean if they went twice as long? If they drove for twice as long, that would be 1 whole hour. And I guess they would drive 60 in the first half an hour and another 60 in the second half an hour. So that would be a total of 120 kilometers in 1 hour, right? And if they did another half an hour, that would be 1.5. How far would that be? About 180. And if they went another half an hour, that would be 2 hours. Well, how far would that be? 60, 120, 180. I'm going to say 240 kilometers in 2 hours. All right? But these numbers on the top, they represent distance. They can be written a different way. In fact, you might be thinking right now that to go from number to number, you add 60 every time, which is a good start. But with repeated addition, we can always represent repeated addition as multiplication. And so what I want you to do, or challenge you to do, is to think multiplicatively. And in fact, you should be able to determine how far they go just by knowing how long they've been driving. So for example, 120 is simply, it's going to seem like a silly thing to say, but 120 times 1 is the same as 120. And you know what, maybe I'll change colors here. Too bad I don't have my smartboard at home. That would be cool. So I'm going to do 120 times 1 and write it that way. Not much different than 120, of course, right? Well, how about this? For 180, I'm going to write that as 120 times 1.5. Because 120 times 1.5, that's the number, that's the time here, would give you 180, wouldn't it? So it's actually the same as this. Let's go backwards here. 60 is actually 120 times a half. 120 times a half is 60. And furthermore, I can say 120 times 2 is 240. So instead of thinking of it as 60 plus 60 plus 60. Let's try thinking of it this way. 60 is 120 times a half. 120 is 120 times 1. 180 is 120 times 1 and a half. 240 is 120 times 2. When we think of it that way, it's easy to convert that to an equation, because our equation is supposed to have distance, and the distance is going to be always equal to 120 times however long they're driving. So instead of 120 times half an hour, 120 times t. Instead of 120 times 1, or 120 times 1 and a half, or 120 times 2, we're just going to say the distance is 120 times however much time they're driving for. And now we've got our equation. We've answered part A, haven't we? There's another part to the question, actually, and it says, what does the constant of variation represent? Well, the constant of variation is this number here. Okay? So the constant of variation and, well, what do you think the 120 represents? What does it mean in this context? Well, it does mean that in 1 hour they go 120 kilometers. That's a bit of a hint, right? So I'm going to say the 120 kilometers per hour is their speed. That's how fast they're driving. I would say that whoever's driving, hopefully they're going on a pretty fast highway, or maybe they've got a bit of a lead foot, but that's their speed or the rate. Okay. Part B says to use the equation to determine how long it'll take to drive to Deep River, Ontario. Well, we've got the equation, so we're going to use it. So here we go. D is equal to 120 t, but in this case, we want to make a substitution. So instead of writing d equals 120 t, we have to ask ourselves what gets substituted, and I would say the distance to Deep River is 500 kilometers. So I want to plug in 500 somewhere in this equation. Where do you think the 500 should go? We definitely want to keep 120 here. But should the 500 go here or here? Well, is it a distance or is it a time? 500 is a distance, so where we used to write d, I'm going to write 500. And by convention, we're supposed to put that in a bracket just to show that we substituted. And here, I'm going to write times t. So now 500 is 120 times some amount of time t. And we have to solve our equation. So we're going to use our equation solving skills. What would you do to solve for t? We want to isolate it, which means we want to undo this division. So I'm going to divide by 120. And over here, I'm going to divide by 120. So 500 divided by 120, so it's 4.166. Let's just write it as t time is approximately 4.2. Close enough. So a little more than 4 hours. And because this is a word problem, you always want to put a statement. Therefore, it will take about 4.2 hours to drive to Deep River. Does that make sense? Take a minute, make sure you understand all of those steps. If you don't, reach out to me on the Google Classroom. You can discuss it with one another. Maybe you can answer each other's questions, or if you post it to me, I can also weigh in, but I think I'd like to see you guys discuss it a little first. Let's move on to the next example.